Hello guys, in this video I'm going to show you how to find the position function from velocity and the initial condition. So you should know that velocity is the derivative of the position, so that the position is going to be the integral of velocity. So let's try to integrate 20 e to the 4t. As you know, derivative of e to the at is a e to the at. But if you do the integral of that, that will be reversed. So what will happen is instead of multiplying by the number, you actually divide by the number. Okay, you can show that by the substitution rule. That's pretty easy. And then you will get that plus c. So what we'll do here is the number 4 that's in the power will cancel with the 20 and make it a 5. And the e function stays I. Now, integral of e to the t is the same. E to the t stays the same whether it's derivative of or integral. 7 is a constant multiple, which we also keep. And that would have been it. But the problem is that whenever we do something like this, whenever we do integration, we always add that constant plus c. Here, though, it's not just going to be a number. It's going to be a constant vector that we do not know. And we will call it plus c, but we'll put a vector notation on top. And it is a vector that doesn't have a t in it, but it could be some numbers. And we need to find it. Well, how do we find it? Well, we find it from the initial condition. Let's go ahead and substitute 0 for t. What do we get? Let's see. So we get 5 e to the 4 multiplied by 0, I, plus 7 e to the 0, j, and then plus c. Okay, let's see what that is. Now, e to the power 0, don't tell me it's 0 because it's not, it's 1. So we get 5, I, plus 7j, and plus this unknown vector, constant vector c. Now, this has to be equal to, because of the initial condition, to 9i. Now we need to solve this for c. How do we do that? Well, we're going to subtract 5i from both sides. And we're going to also subtract 7j from both sides. So this is going to be minus 7j. Okay, so let's see. Then c will become, so 9i minus 5i, that's 4i. And then minus 7j is what c is. We are basically done, except now we have to take the c and we have to plug it back in here, and we have to collect like terms. And so let's see if we can do that. So we've got 5 e to the 4ti plus 7 e to the tj, okay, plus this vector c, so plus 4i minus 7j. We do want to combine like terms, and by like terms I mean the terms with I and the terms with j. So the term with I will become 5 e to the 4t plus 4i, and then the term with j will become 7 e to the t minus 7j. Now, just to make sure, always check, is the initial condition satisfied? Because if it is, then you got good. If you were to plug 0 in for t, you will get 9i from the first term, and from the second term, you'll get e to the 0 is 1, 7 minus 7 is 0. So that'll just be 0j. In other words, that should be 9i, right? And that was the initial condition that we have here. So check, and that means that this answer right here is correct.